Sound travels at different speeds depending on the type of media. So I've got some examples here. We've got gas, liquid, and then solids. Firstly, let's do air. I'm going to say at 0 degrees Celsius, and it's got a speed of sound in meters per second of 331 meters per second. Now, sound actually travels much faster in a liquid than it does in a gas. So in water, the speed of sound travels at 1,140 meters per second. So significantly faster, almost 4 times faster. Now, let's have a look at steel next, or a solid, before we talk about why. So in a solid, sound actually travels even faster again. In steel, sound travels at 5,100 meters per second. So it's significantly faster. So you see that in solids, sound travels faster than it does in liquids and gases. And this is to do with particle theory. In solids, particles are closest together. So because the particles are closest together, they more readily and more easily transfer the energy from particle to particle. Now let's have a look at air that's warmer. So as we increase the temperature of the air, the speed of sound actually increases. So the speed of sound in air at 18 degrees is faster than it was at 0 degrees. And again, this is actually related to particle theory. As we increase temperature, we have an increase in the speed of sound. Now, this is related to the fact that with an increased temperature, particles have more energy, so they're vibrating faster. They have more energy, they're vibrating faster, so they more readily pass the energy, the vibration, on to the next particle. So we can use particle theory to explain why solids, why the speed of sound is faster in solids, because particles are closer together. We can use particle theory to explain why, as we increase the temperature, the speed of sound also increases. And this is because of the amount of energy in the particles. The particles are vibrating faster, so they more readily transfer the energy of the wave.